Alright, so here's the first part of 5.3 using algebraic techniques to solve. We can go ahead and get started with number 1. You can look at the examples later since this is a review. Alright, so solve each equation for all values of x. So where does cosine of x equal -1? All students take calculus. Well, -1 isn't going to be in one of the quadrants. So it's going to be one of the quadrantals. This is 1, 0. That's where cosine is equal to 1, because remember cosine is the first value. Here we have 0, 1. Well, that's where cosine 0. What about here at pi? Right, because we tried 0, pi over 2, and pi. At pi we have -1, 0. Hey, look, that's where cosine of x is equal to -1. So here my x is equal to pi plus 2 pi n. Because we have to say for all values of x, aka plus 2 pi n. Number 2, sine cubed x minus 4 sine x. So notice that there's a sine in both terms I can pull out. So I'll have sine squared x minus 4 equals 0. Well, that's a difference of squares, so I can write this as, just a reminder, a difference of squares. If I have x squared minus 4, I can write it as x plus 2, x minus 2. X minus 2. So that's what difference of squares is. So down here, I can say this is equal to sine of x minus 2 and sine of x plus 2. And then I'm going to take each one, set equal to 0. So here, sine of x equal to 0. Where is sine equal to 0? Well, I started drawing it over here. Sine is our y. Check it out. Here's where my sine is equal to 0. So I have 0, pi. Those are where it is, but I need to say for all values of x. So I can say x is equal to 0 plus 2 pi n. I can say x is equal to pi plus 2 pi n. Or, since it's going to be alternating 0, pi, 2 pi, 3 pi, 4 pi, 6 pi, blah, 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 I can say x is equal to 0 plus n pi. Because then it'll hit both, like both 0 and pi. Here, sine of x minus 2 equals 0. So I'll have sine of x equals 2. That's false. It's never going to happen. It does not exist. Sine is only oscillating between -1 and +1. It'll never equal 2. Same way here. Then I have sine of x plus 2 equals 0. So sine of x equals -2. That does not exist. So we only really have one solution, 0 plus n pi, or you could say 2, 0 and pi, and both of them are going to be plus 2 n pi. Alright. Sine x, cosine x minus 3 cosine x. Notice that we have a common term. We have cosine x in both terms. So I can pull that out front. So I'll have cosine x of sine of x minus 3 equals 0. Take each one of these, set that equal to 0, right? So I pulled out, I factor out a common term, and then I set each of my factors equal to 0 for the solution. Cosine of x equals 0, so where is cosine equal to 0? Where is my x equal to 0? Well, that's going to be at pi over 2 and at 3 pi over 2. Don't forget, we have to do it for all solutions. Okay, so there's that one. And then the other says sine of x minus 3. So sine of x minus 3 equals 0. So where does sine of x equal 3? There's no solution. Does not exist. There's no angle where sine will equal 3. Number 4. Let's see. So I have 2 sine cubed x equals sine x. So if I move this over, 2 sine cubed x minus sine x equals 0. Pull out a sine in front. Sine x. 2 sine squared x minus 1 equals 0. Yeah, I factored out a sine x since it's in both terms, right? And then I'm left with 2 sine squared x minus 1. So I take each one of these factors, set it to 0. So sine of x equal to 0. Where is sine equal to 0? Where is sine equal to 0? This is 1, 0, so at x equals 0, and negative 1, 0, so at x equals pi, but we need to include all solutions, so I have to do plus 2 pi n. And then I can take my other one. 2 sine squared x minus 1/2 equals 0, add 1 on both sides, and divide by 2. So sine squared x equals 1/2. So I add 1 on both sides, so 2 sine squared x equals 1, and divide by 2, so sine squared x equals 1/2. Square root on both sides, so sine of x will be plus or minus the square root of 1 over square root of 2. Because I square root of both sides, and so square root of 1 is 1, square root of 2, well, that's just square root of 2. Another way to write this, and normally I rationalize it, would be square root of 2 over 2. That's plus or minus. So where is sine equal to square root of 2 over 2? Here, here, because don't forget we have plus and minus. So every one of these has a reference angle of pi over 4. Pi over 4, pi over 4. So I have x is equal to pi over 4. This one, to get to here, is x is equal to 3 pi over 4. To get all the way to there, x is equal to 5 pi over 4. And then, to get all the way around here, of x is equal to 7 pi over 4. And of course, we have to go back to every single one of these and say plus 2 pi n, plus 2 pi n, plus 2 pi n, plus 2 pi n. Oh my gosh, so we have 6 solutions. Yikes. That's cool. Alright, so we're half done with this one. This is a much shorter lesson. Alright, now let's find all solutions of each equation on the interval between 0 and 2 pi, aka we'll find the solutions. We don't have to add that funky little plus 2 pi n. Alright, to get cosine by itself, divide by 2 on both sides. Where is cosine of x equal to 1/2? So cosine would be half up here and down here. Here's the angle, don't forget, so COT, so the adjacent is 1/2, the hypotenuse is 1. This is a 30 degree, so wait, this must be 60 degrees. So this is a positive 60 degrees, so pi over 3. And then we also have to, so we have the 60 degree, and then we're also going to have this all the way around. This will be pi over 3 less than 2 pi. 2 pi minus pi over 3 is 5 pi over 3. Cool. Those are the two solutions. Let's try this next one. So this is similar to what the last question, was on your quiz. So I need to get sine of x by itself. First, I'm going to combine like terms. 5 minus 7 is negative 2. So 2 sine x minus 2 equals 0. Add 2 on both sides. 2 sine x equals 2. Divide by 2 on both sides. Sine x equals 1. Where does sine equal 1? Pi over 2. We only have to solve between 0 and 2 pi. Number 7, 4 sine squared x, tan x equals tan x. Ugh. Alright, so I want you to pause the video, try to solve this one, and then we'll go over it together. So right away, let me minus tangent from both sides so I can get on the left side. I see I have a tangent as a common term, so I pull it out front. And then I have 4 sine squared x minus 1. Well, that's a difference of squares. 2 sine x plus 1, 2 sine x minus 1. 2 sine x minus 1. Cool, so that's a difference of squares, because if I multiply these back together, I get 4 sine squared x minus 1, and then the middle term goes away, difference of squares. So now I'm going to set each one equal to 0. We'll see what we get. So tangent of x equals 0, so where does tangent equal 0? To answer this question, you know tangent is just sine of x over cosine of x. So in order for this to equal 0, what I'm really asking is where does sine equal 0? So sine equals 0 at 0 degrees. Oops. And at pi. Those are the only two places sine is equal to 0. So if I would put in my values at these 2 points, I have 0 over 1 equals 0, and I have 0 over negative 1 equals 0. So those are the only 2 points. X is equal to pi and 0. Alright, we can do the other ones. So I have 2 sine x plus 1, 2 sine x plus 1 equals 0, minus 1 from both sides, and divide by 2. Where is sine equal to negative 1/2? Well, let's see, negative would mean it would be down here. Oh my god. Ah! Oh my god. It'd be down here. Okay. That's where sine, all students take calculus. That's where sine's negative. Let's see, so if I draw this triangle, here's theta, sine SOHCAHTOA, so the opposite's negative 1/2. Oh my gosh, it's going to be 30 degrees. Here's 30 degrees, here's 30 degrees. So I know that this is going to be 30 degrees is pi over 6, so x will be 7 pi over 6. And 11 pi over 6, because it has to be between 0 and 2 pi. It can't be negative. So those are for that one. And then the other one is going to be, let's see, 2 sine x equals 1. So where is sine of x equal to 1/2? It's literally going to be the other two angles from what we just drew. So that would be up here and up here. So where is sine equal to 1/2? It would be positive 30 degrees. So right here, this 30 degrees is pi over 6. So x, oh my god, x is equal to pi over 6. And we have 5 pi over 6, because I'm 1/6 less than pi. So I have 6 solutions. My goodness. Cool. All right. Here's the last problem of this set. 2 cosine x minus square root of 3 equals 0. Add square root of 3 on both sides. Divide by 2. Where is cosine equal to square root of 3 over 2? That seems like a 60-degree angle to me. Here's theta. So SOHCAHTOA, right? So adjacent is the, oh man, square root of 3 over 2, hypotenuse is 1. So I recognize it's a 30, 60, 90 triangle. It's just, you gotta be careful when you're like blurting out, because notice, oh my god, I was totally opposite. Here I'm dealing with a 30-degree angle. Yikes. All students take calculus. Let me make sure I get my two angles right. So here's the positive x, here's the positive x. So this is a positive 30, and then I'll have 330 degrees. So I have x is equal, oops. So x is equal to pi over 6 and 11 pi over 6. So I figured that out because I have pi over 6 here. And then I go all the way around and I have 2 pi minus pi over 6. And that gives me 11 pi over 6 because I want it in terms of the positive angle. Alright, that's it for this part. Let me know if you have questions. Alright, have a great rest of your day.